Good evening, everyone. So before going to the Masterclass 2.0 content, so I would like to congratulate the top 15 teams who have gone through the Kaggle competition successfully. So today we have Anuk Dissanayake with us, Data Science and Engineering Associate at Octave, and I'm Kiruparan Balachandran, Senior Data Scientist at Octave. So the today agenda or the discussion is based on the Kaggle competition. You guys went through it. So the Kaggle competition is based on the sales forecasting problem, right? So the agenda today is we'll take the sales forecasting problem, and we'll discuss a little bit about how this is related to regression, right? So once that is done, we'll also discuss at Octave, okay, how we are solving these forecasting problems. So there are different stages you have to go through it, right, to build a sales forecasting model. So once that is done, so if you take sales forecasting at Octave, or if you take the supermarkets, they focus on two different areas known as over forecasting and under forecasting areas. So we'll do a deep dive on that as well. Then, like based on the business needs, sometimes they want to reduce the under forecasting errors. So we'll discuss few approaches how we can reduce the under forecasting errors. So that is the agenda for today. Anuk?
Yeah. On Masterclass 1, we discussed what a regression model would do and about the relationship between the independent variables and the dependent variables. So on Masterclass 2, we plan to discuss how we could use the core principles of regression analysis to forecast the sales. So if you could stay on the screen, yeah. So here, we have a question where it is required to forecast the quantity sales for day 30 and day 31. So over here we have a graph where you have on the y-axis the quantity sales and on the x-axis the day of the month. The question is to figure out what would be the sales on day number 30 and also on day number 31. So guys, any one of you have an approach to understand what would the sales be for day 30 and day 31, or even a random guess would do?
Guys, this is like a more interactive session, so it's good if you can unmute yourself and answer these questions.
All right, just to give some context, so now here we know the sales, as you can see. So on day 1 we can see sales of 55, then it has kind of dropped, dipped and gone down, and it has gone up, right? So the pattern is not consistent, right? Now sales forecasting, so if you take sales forecasting in general, right, so most of the time the sales are uncertain, right? Now when it comes to sales forecasting, it helps these businesses to understand how the future sales could look like based on past sales, right? And on this masterclass too, and during the course of the next few slides, so what we'll do is we'll discuss how we can solve the real world sales forecasting problem, right? So let's move on to the next slide.
Yeah. So if you take the sales forecasting program, so if you take at Octave, we do this in different stages, right? So maybe Anuk, if I ask you a question, right? Let's say you are a part of this competition, and if we once you receive this problem statement, right? What are the steps you will follow to build a very good model? First thing, like, do you follow model steps?
Now, at Octave, like when it comes to steps, so there's actually no standard way of doing it, right? So you could like, first of all, one of the most important things that you need to know is you need to understand the business context, right? Now, when it comes to solving a problem, you need to have an idea as to why you need to solve it. And once you have an idea as to like, why you need to solve it, you should have a kind of a strategy to solve this problem, right? So like in terms of these steps, like there are multiple ways you can end it, but one of the major things you should do is you should know like what your what variable you need to solve for, right? So you need to know what your y variable is, or in other terms, the target variable, right? So that could be the first and foremost thing you need to figure out, right? So as you can see, we have some steps aligned. So you need to first of all define your target variable, and then you need to like figure out what your x variables would be, and then you can define, if you're training a model, what would be the training and testing periods. And also there are some steps, right, like feature engineering, exclusions, and outlier removal, and defining these accuracy metrics. So Q, you want to take
Yeah, so like, exactly, Anu. So you are so like you said, Anu, based on the business problem statement, you have to define the target variable, right? Anyhow, we'll do a deep dive on how we can define the target variables and all. Let's say based on the problem statement, once you identify the target variable. For an example, in the Kaggle competition, we were asked to predict the sales 1 week in advance, right? In that case, the sales for the next week is your target variable. So once you identify the target variables, you need to come up with the proper train and test periods, right? So once you have the target variable and the train and test periods, so you have to do a deep dive and see like how exactly you can relate this target variable, okay, to the external factors known as features. Okay, it can be a raw features, or else you also come up with more synthetic features, right? That means you can build features on top of the raw features. Also, the key thing is once you identify the target variables and train test periods, and also once you have the features, you'll have noises in your data, right? So you need to remove those outliers. So we'll do a deep dive on that as well. Once you identify these outliers and all, you have to define the proper metrics. Okay, so if you take the Kaggle competition, so the metrics is the mean absolute percentage, right? So based on the business problem and based on the business need, you need to come up with the proper metrics. Okay, this is a 4 stages process we follow at Octave to build a sales forecasting model. So if you take the first step, okay, we were discussing, we need to define the target variable, right? So let's say a sales forecasting problem. So you want to predict the sales for the next month, right? In that case, the next 4 week sales is your target, right? And also like you need to know the data you have, right? So for an example, if you take this particular problem, we have 3 months of data to predict the next 4 week sales, right? In that case, your trained data is 3 months worth, and you have to predict the sales for 1 week, 2 week, 2 weeks, 3 weeks, and 4 weeks in advance, right? Anuk?
So moving on now, we'll move to another exercise. Right now here, so the question is, so here we have a graph which represents the sales quantity day wise, right? I want you guys to figure out what would be the sales for this particular item ABC on day number 6 and day number 7. So as you can see, we have a bit of low sales on the first day, then it has increased, and from day number 4 it has gone down and come out to around 25 on day number 5, right? So the question is to figure out what would be the sales for day number 6 and day number 7. So here there are 3 options. So which option do you think would represent the sales for day 5, day 6 and day 7?
Guys, even you can type the answer in the chat as well.
So do you think like whether the sales would increase, or will it remain the same, or will it decrease?
Anuk, maybe you can pick random.
Yeah. Yes. So uh, yeah. So yeah, maybe someone, does anyone want to comment? Yeah. Even a random guess. All right. So in this case, actually, we can't say like the sales could either decrease or increase, or it would remain the same. So the reason being, like, first of all, we do not know what this item would be. So it's basically it says item ABC, right? And in order to, like, forecast the sales for 2 days or even one day, we should know more information, right? So ideally, in this scenario, the answer could be either A, B, or C, right? So if we can move on to the next slide. So here, yeah, here now we have a little bit more information. Now on this question, the objective is to understand the sales quantity for this particular item on day number 6 and 7. And now we know the days of the week, right? So the days of the week are Wednesday and Thursday, right? So we have sales on Friday, and it has increased on Saturday and further increased on Sunday, and then it has gone down. So now what do you think the sales would turn out to be on Wednesday and Thursday? Now it will be a little bit easier to understand now that we know the day of the week.
So Anuk, you are saying like now we have more features to identify the sales, right?
Yes, an additional feature, that is the day of the week. Right. So ideally speaking, like when it comes to retail, right? So most business domains, when it comes to, like, in this particular problem, you would expect there'll be a high sales during the weekends, right? So that is Saturday and Sunday, right? So when it comes to this question, it's highly unlikely that the answer would be A, but more often than not, the answer could be either one of B and C, right? But then again, we cannot say in confidence that you can exclude the option A. But as per this slide, the possible answers, your choices could be answer B and C. So if we could move on to the next slide. Yeah. So now on yeah, just wait for it. Yeah, now on this slide, so we have some more information, right? So we have the same sales trend. So here earlier when we started, we just had the information of the days, right? So we had day 1, day 2, day 3, day 4, day 5, day 6, day 7, so on. And then next we knew what the day of the week is, right? So we knew whether it's a Sunday or a Saturday or a Monday or a weekend or weekday, so on. But now we have some additional information. So we know the date component as well, right? So you would see starting on the December 19th, 20th, and up to the 23rd. And the question is now structured in a way that you need to predict the sales on the Christmas Eve, that is the 24th of December, and also on the day of Christmas, that is the 25th. So what do you think the sales would be?
And you are saying like in 24th we'll have more sales compared to 25th. That will answer A.
Yeah, so a possibility would be answer A, because like when it comes to the retail domain, so mostly um, the day before Christmas and also Christmas Day are high sales days, right? So according to this information which we have, possible answer would be A, right? So we could kind of disregard option B, where we have the sales going down, and an option C, which is kind of stabilizing, right? So as per this slide, the answer should be A. So, Kiru, you want to add anything?
No, go ahead.
Yeah. So let's move on now. Yeah. Now, this whole concept of understanding how different features, impact the sales pattern when it comes to predicting the sale, this concept where we, leverage different kinds of data to understand how these features behave. This concept is known as feature engineering. Right now, when it comes to this concept of feature engineering, there are different features we could engineer. That means different features, we can create in order to make sure that we can, predict our sales in such a way that whatever the error we have would be as minimum as possible. Now, when it comes to engineering or recreating these different features, there are multiple ways. So now one of the ways which we did earlier was that we understood what the day of the week was, right? Now, these features are part of these time related features where, for example, we can understand what would be the month or the week or the particular week of the year. And in our case, on the previous slide, we saw based on the day of the week how the sales would change. So that's part of the time related features. Then we have these promotional features, right? Now these features are also vital when it comes to predicting the sales. Now, for example, now if there's a promotion, right? A promotion is an instance where you give out items in a price which is where the customers are able to buy the products in a lower price, right? Now these features such as the percentage of sales that happen during the promotion, then quick sales, like these quick sales are instances where the items are given at a lower price where the customers would be enticed to buy more items. So these kind of features are also contributing to the sales, right? So next we have this seasonal impact, right? Now where the sales could be determined based on the time of the month, whether we are at the beginning of the month or at the end of the month, and also based on whether the particular day is a holiday or a regular day. So that was the case which we discussed on the previous slide. So we saw that during Christmas Eve and on Christmas Day we could expect a high number of sales. Also during the course of the season duration, we can create features to understand its seasonality. Then we have another driver that is based on the product, right? Now, an example would be based on the price of the product, right? Now, if the price is a little bit on the lower side, we would expect customers to buy more products, right? So that's another scenario, and also the category of the product. Now, as you would have noticed, now during these times we would see certain categories are having higher sales compared to much higher sales compared to the other categories, right? So that's also another driving factor. For example, like would see items such as milk powder would be on higher demand, right? Then another driver would be the outlet, right? So based on features of the outlet such as the size, then the product assortment, and also attributes like the location of the outlet, that too will drive for higher sales or even lower sales for that matter. And last but not the least, the most I would say influential aspects would be the transaction trends, right? So the past transaction trends play a pivotal role, right? Now, for example, we mentioned some example. It could be for a particular period, for that particular item of the store, what would be the number of transactions. Also, there can be instances like during that particular period, how many customers visited the store, then the daily sales, also the number of items sold, and also the number of items which are actively selling. And also this time period could vary. So here on this example we've taken 30 days, but it can even be 3 months or 6 months. So based on the problem we are solving, you can vary the time period as well. So you can even go with a lower time period to capture certain aspects. So this depends on the business context as well. Yeah. So moving on. So now when it comes to this concept of feature engineering, so what we do is we recreate new features so that these features we expect would have more capability to predict, would have more predictive power than having the raw data. So basically what we do is we transform the raw data in order to create new features, right? Now, when it comes to these methods of feature engineering, there are multiple ways you can do it. So we have these techniques such as aggregations, calculations, transformations, and finally dimension reduction. Now, when it comes to aggregation, so the common ways which you can aggregate features would be using the average. So that's one of the go-to techniques, and also we can consider standard deviation, the minimum, maximum, or even we can consider. Yeah. So next we have the calculation, right? When it comes to calculation, so we can consider this example such as we can take ratios, right? So if there's a particular period, so we can take the ratio of sales compared to another period, and also we can create lag features as well as lead features. So by lag features, what we mean by looking at past few days of sales, we can for example understand what would be the sales, and also using these lead variables we can get the sales based on some future dates, right? And when it comes to transformations, so this too is a common technique where we can standardize our variables, then do some log transformation so that we can increase the predictive power, and also we can use certain dimension reduction techniques such as principles component analysis, where which is commonly used. For example, if we have a substantial number of features, we can, by using principal components analysis, we can pick a lower number of features which explain the exact same variance, right? So then we can use further we can use techniques such as clustering as well. Yeah. Now when it comes to this feature engineering, now these features which we create using these operations such as aggregation and the other arithmetic operations such as subtraction, addition, and all. So these features are known as synthetic features, right? So these are additional predictive features which we can create using the raw data, right? Now, for example, suppose we have a feature such as the daily sales quantity, right? Now, for example, we have a value of 200. For example, it can be of a particular store item, the sales, right? But having that particular feature may not be enough in order to predict that particular store's items future sales on a particular day, right? So what we can do is we can derive features, right? So these features which we derive are the synthetic features. And for example, what we can do is we can come up with, for that particular item on the past month, on that particular day of the week, what would have been the average sales quantity, or even we can take during the past week, what was the average sales quantity, or we can take something like the maximum sales quantity, or even the minimum sales quantity, right? So there are multiple ways we can, numerous ways where we can create additional synthetic features, right? Now, another example would be, suppose we have a date, right? So by looking at it, it will remain just a date, right? But we can, identify a lot of hidden information even by looking at the date, right? So these synthetic features where we can create using a date would be, for example, on the date, we can consider the year, then the month, then also the particular day, the week, or even if we have just the day of the month, then the particular week where the day falls of that year. So there are numerous features where we can create in order to increase the predictive power of the model which we are going to feed. Right? So these features are called synthetic features. Right? So we move on. Yeah, now here we have an example where we are going to create some synthetic features, right? So coming back from the previous slide, now here what we are going to create is the sales of the previous day. That is, for example, on this particular item ABC, what we are going to do is we are going to get the previous day sales. Now here, if you look at the 1st of March, since our data starts from the 1st of March, we wouldn't have previous day sales. Right? But for the following days, we can easily derive the previous day sales, right? Now, by doing this, what we would be able to do is we are able to enhance the predictive power of the model, and this additional attribute which is derived would be the synthetic feature sales of the previous day, right? So there are other examples as well. So we'll look how we can use this synthetic feature, right? So moving on. So here we have a scenario where we have considered the average sales of the previous 3 days. So it's the same example, but instead of taking the previous day's sale alone, here we have compiled kind of a moving average, right? So here, so for the first 3 data points, the average sale would be the previous day average sales for the next attribute, right? So that is on the 4th of March, the average sales of the previous 3 days would be the average of the sales from the 1st of March to 3rd of March combined. And then on the 5th of March, that will be the average sales of the following 3 days. That will be the average sale of 2nd, 3rd, and 4th, right? So also these periods could be like, relative. So you don't have to go with a fixed period, like, 3 days, previous 3 days. So you would need to know, you would require to have some business domain knowledge as well. So it could be even based on the situation, it could even be previous 7 days of sales, or even the past 2 weeks of sales, or you could even consider, like a larger period, like, past 3 months of sales, right? So it will depend on the context as well. Moving on. So here another example would be using the maximum sales of the past 5 days, right? Now here also quite similar to the previous example. So we have for that particular item the daily sales, and here what we have done is from 6th of March onwards we have the maximum sales of the previous 5 days, that is from March 1st to March 5th onwards. So over here we have 50, which was the highest data point, and for the 7th of March also, from 2nd of March until 6th of March, we have the value 50. So to add on to this, it's quite similar to the previous example. This time period could be varied. So we can even go with the maximum sales of the previous 3 days, or 7 days, or 2 weeks, based on the business context. Also, similar to that, we can even look at the minimum sales as well. So here it's quite similar. Like the maximum sales, we have considered the minimum sales, and now the time period has decreased. So it's the previous 3 days, right? So here we have values from the 4th of March onwards, that is the minimum sales of the previous 3 days. So here you would have a value of 20, which is the minimum sales of the previous 3 days, followed by the value 30, so on, right? And also similar to the previous context, so the period could vary. So it can be 3 days, or even a higher or lower period, based on the problem you intend to solve. Yeah.
Thanks, Anuk, for the very insightful detail about the raw features and synthetic features. I think we can easily correlate this with the Kaggle competition as well, because even the Kaggle competition, we shared very few features, right? So let's say if you guys build, if you guys come up with more synthetic features, you can have more accurate model. So far we discussed about features and the synthetic features. So now you are ready to build the model, right? So before you even to build the model, you have to look for these outliers in your data. For an example, if you take even if you take the Kaggle data, right? So we have shared the data contains for around 200 items, but not all the items will have enough sales data, right? So if you see this graph, so if you see item 8 and item 11, so these have less sales data, right? So if you use this data to train the model, actually you are adding some noise to the model, right? So maybe you'll end up, let's say here for the item 8 and item 11, you have very low sales, right? Or even you don't have enough data. So if you use this data to train your model, sometimes you're adding more error. So how you can handle this one is, so when before you build a model, so you have to do some descriptive analysis, or you have to do some analysis and see whether you have enough data point for each item. And let's say if you don't have enough data for each item, let's say here for item 8 and item 11, you have to treat these guys separate. You should not use these data points to train your model. Maybe for this item 8 and item 11, you can simply come up with a moving average prediction. You should not build a linear regression, or you should not build a boosting models. So like once you now you have a clear understanding about the features, synthetic features, and even we discuss about how we can remove the outliers, right? So now you have trained the model. So now we have a very critical part. You have to select the right metrics, because if you just do a Google search for a regression, okay, you will end up having different metrics like R squared, root mean squared error. Here I have listed like few metrics like mean average error and average map, total map. So based on the business need, you have to select the right metrics. So let's say mean average error. So Anuk, I think you worked on these problems, right? Can you tell me why we can't use mean average error for this particular sales forecasting problem?
Yeah, so good point, Kiru. So now when it comes to the mean average error, now different items would have like varying sales, right? So you would want to know, now ideally speaking, when you want to know the error, you would want to like know the error based on a particular like proportion compared to the sales, right? So in that case, the mean absolute error in this scenario wouldn't like give you a clear understanding in that sense, right? So in that case, like
Exactly. Yeah. So like Anuk said, if you take the mean average error, so there is no way you can normalize this error for the actual sales, right? So here you are only considering the error. Then again, if you take the average mean absolute percentage error, right? So how they are computing is it's based on the absolute error and the actual sales, right? So let's say for an item, if you have zero sales, you can't go with this particular metric. So that's why, like, if you take even the Kaggle competition, so we ask you to compute the total mean absolute percentage error. So this is a very common metrics we use in the sales forecasting problem, because here like we discussed two issues, right? First thing is like you can on the mean average error, you can't consider the actual sales, right? On the average mean absolute percentage error, you can't treat the zero sales, right? Uh, these two issues you can treat in the total mean absolute percentage error. So of course there are some other metrics like root mean squared, logarithmic error, and all. But very common metrics we use in business is total mean absolute percentage error. So far we discussed about sales forecasting problem, and we discussed we did deep dive on the regression and what are the stages we follow when we are building the model, right? So now you have the model and you have the metrics and you are computing the error, right? So if you take a sales forecasting problem, so at business or at supermarket, we focus on two key errors known as over forecasting and under forecasting. So on the next few pages, we'll do a deep dive on this over forecasting and under forecasting. So over forecasting means, let's say, for ginger beer, right? Your model says the sales is 200 units, right, for next week, but the actual sales is 100. That means actually your model over forecasted, right? So the error you are getting from that is over forecasting error. So the problem, like let's say if you are doing over forecasting, if you take the previous example, the model says 100 units and model says 200 units and the actual sales is 100, right? So there's 100 units remains, right? So let's say at supermarket, they had to keep this stock somewhere, right? So you're adding some stock holding cost. Then again, it depends on business. So sometimes they are okay to have this stock holding cost. So on the other hand, if you take the under forecasting error, let's say your model of the same ginger beer, your model says 100 units. Okay. So if it is under forecasting error, you'll see your model says 100 units, right? So it says the sales going to be 100 units, right? But you have 200 unit sales. Okay, that means your model actually did an under forecasting, right? So in that case, we are going to like you don't have enough stock to make the sales, right? So that means there's a out of stock. You are going to have the out of stock. So based on the business need, sometimes business want to optimize towards the stock holding cost. Sometimes the business want to optimize towards uh, the loss of sales or the under forecasting error. So based on the business need, you have to play with this under forecasting and the over forecasting errors. So like so far we discussed about the over forecasting and under forecasting error, but so once you have the model, right, you can't change anything. But there are certain descriptive methodology you can use to avoid this one. So common approach is we use a buffer. So how we use the buffer is, let's say, if you take this particular scenario, okay, uh, the prediction is in the dotted line, okay, on a given point, the actual sales is higher than the prediction, right? That means we are doing an under forecast. So what we can do is to reduce this error, you can add a buffer, okay? So there are different approaches we follow. So here what we do is we take the error and we understand the error distribution. Based on that, we come up with a buffer. So here the buffer is the under error, the average under forecasting error plus 2 standard deviation. So once you add this buffer, you can see the pink color one that is with the prediction plus buffer that is higher than the actual sales. Of course, here you are introducing some over forecasting error, but that is fine. It's up to business. So if they want to reduce the under forecasting error, if they want to reduce the uh, loss of sales, it's okay to add the buffer. So this is a very typical scenario. Let's say, so like I said, we are computing the accuracy using mean absolute percentage, right? So without the buffer, the accuracy, the error is 17%. That means the accuracy is 83%. The under forecasting error is 12%. So once you add the buffer, you can see the under forecasting error drop to 2%. But also you can see the overall error. So it raised up. So previously it was 17%, now 24%. But again, like I said previously, it's up to the business. If they are okay to keep the the overall error to 24% by reducing the under forecasting error, that is fine. So the key takeaways, guys, here. So we discuss about the regression model. Also, we correlate how that uses in the sales forecasting problem, right? And also we discuss the stages. What are the stages we have to follow when you are modeling the sales forecasting? Also, we did a deep dive on the under forecasting and over forecasting errors. And also we discuss how we can reduce the under forecasting error by applying a buffer. I can open for a questions. Guys, if you have any question, you can raise. You can unmute yourself and ask. Okay, I think there's no further questions. So guys, wish you all the best for the semi-finale and the finale. So we hope we'll meet in person in the finale on Saturday. Thank you, guys.
Thank you very much, sir. Let me remind our participants that Masterclass 2.0 will be the guidance we offer you before the actual commencement of the competition. So this is your chance to direct your questions and clarify all your doubts. Please feel free to unmute yourself and direct your questions to our panelists. And also, please feel free to type in your questions to the chat box so that I can direct your questions to the panelists. This is a reminder to all our participants. Okay.
Bihar, I think there's a question. Can we
Yes.
have multiple target variables for a model? So it was from Danujaya. So Danujaya, so of course it's possible. Even if you take this particular problem, right? The Kaggle competition. So you have to, there are 4 targets, right? So you have to predict sales 1 week, 2 weeks, 3 weeks, and 4 weeks in advance, right? In that case, it's up to you, Danujaya, whether you want to go with one model or 4 different models. So let's say if you want to go with the 4 different models, you need to have 4 different targets. But for a single model, especially when you're solving a regression problem, it's not advisable to have multiple targets. Danujaya, does that answer your question? You can unmute yourself and talk.
Yes, sir. Thank you.
Yeah, there's another question from Anuki. What is the best way to deal with missing dates in the sales data? So Anuki, even if you see the Kaggle, if you refer this Kaggle competition data, for let's say for an item, you will not have sales for all the days, right? So this is purposely done because you need to handle from your end. Like even if you take a supermarket, okay, for ginger beer, right? So you will not have sales for all the, let's say, March. You will not have sales for all the day, right? So in that case, if you take the one option is you can take an assumption, okay, for let's say 23rd of March, you don't have any data points. In that case, maybe you can consider that as a 0 sales. The reason is, Anuki, if you don't consider it as a 0 sales, and if you just ignore it, and if you train the model, so your model now learns toward a higher number. Okay, so it's bias. So you are giving a bias. You are letting the model to learn towards a higher number. Okay, so if you're on that place, if you handle this missing data properly, if you add that for the missing dates, if you add the zero sales, actually you are balancing the data, right? That means your model learns all the variance. Anuki, is that answer your question? Okay. Anuk, maybe you can give I think you worked on similar problems like sales forecasting and all. Like, what do you think? Like, do you have any other alternative way to handle these missing dates?
Yeah, so yeah, for missing sales, I would say on this instance, the best way would be to replace with a 0 now in terms of, since you don't have the sales for that particular day. But coming back to another point, like if it was for now, since this is a time series problem, obviously it will more often than not would be zeros which we would have to replace, right? But there are other ways also where you can other techniques which you could use to impute this missing cells. So some of the common ways you can do is you can use this median, mean, these techniques, but on this context, the ideal way would be to simply replace with a zero, because simply we do not have sales for that particular outlet item combination.
Yeah, exactly. Even Anuk, like in the same model, like you submit to the title competition, maybe you can give a try. Maybe tonight you can, for the missing dates, if you replace it by zero sales, you'll have better accuracy.
Excuse me, sir, you have muted yourself.
Sorry, my bad. So when try to predict for the next 4 days, can we use the prediction from first day to predict sales for the second days and so on? Gajitra, it's a good approach. Only thing is, Gajitra here is like, see, like you have a model, right? You have one model, so you are saying you are going to predict for the next day, right? For the following day, you are going to use the same data. You are going to use a prediction to predict for the second day, right? Let's say the Gajitra, you have an error. Okay, let's say you have 30% error. Okay, from the first day. So you are taking that error for the second day calculation as well, right? So worst case, you can go for this approach. But the ideal way to solve this is Gajitra, to have two models. Okay. So let's say if someone asks you to predict sales for first day and second day, you can have two models to predict the next day sales and the second day sales. In that case, you need to define that you need to have two different target as well. Okay, based on the current date, what will be the sales for the next day and what will be the sales for the second day. Okay, you will have two different targets and you can have two different models. That is the ideal way of solving this problem. But of course, you can use this one. Even in other use cases, we have used this one. But what we notice is you are taking more errors to the next iteration. Gajita, does it answer your question? I think we have very good questions actually.
So this is a reminder once again for all our participants. Since we are running out of time, please do direct your questions if you have any more questions. If you have further questions, please do feel free to ask now. So I think we have reached the end of today's session. In the absence of further questions, let me take this opportunity to thank the professionals, Mr. Kiruparan Balachandran and Mr. Anuk Dissanayake, who joined us today amidst their busy schedules. Thank you very much for this very informative session, which I think covered everything that our team members needed to clarify before their competition. It was a great honor and a pleasure to have you with us here today. Thank you very much.